Okay, so here are a few examples using inverse trig functions with derivatives. So here's the first one: y equals inverse sine 1 over inverse sine of x. This is the derivative of inverse sine of x. It's up to you. You could do quotient, but I think the easiest way for this one, honestly, is just to rewrite it as y equals. And I know it looks kind of funky. Inverse sine of x to the negative 1. Because then you can just do your power rule with the chain. So negative 1 times inverse sine of x to the negative second, and then times the derivative of the inside. Well, that's easy. That's just 1 over square root of 1 minus x squared. And then, just to clean it up, we just move the part that has a negative exponent, this guy here namely, to the denominator. So dy dx equals negative 1, because it's negative 1 times 1, over inverse sine of x squared times the square root of 1 minus x squared. Okay, next one. X times arctan root x. X times arctan root x. Now the derivative rule for arctan or inverse tangent is 1 over x squared plus 1. This one's nice and easy because it's really just pretty much a simple product rule. Here's your first function, here's your second. So f prime of x, derivative of the first times the second, plus the first times the derivative of the second. Well, that's going to be 1 over the x squared plus 1, but instead of being x squared, it's going to be root x squared plus 1, and then times the derivative of the inside, which is going to be, this derivative, it's x to the 1/2. So it is 1/2 times x to the negative 1/2. Okay. So really this is just going to be some cleanup on this right-hand side here. F prime of x is going to be arctangent of root x plus, x will go on top, x squared plus 1, root x squared plus 1 will be x plus 1. And then it's times a 1/2, so we'll put a 1 and a 2 out there. And then x to the negative 1/2 moves us down to x to the 1/2. This is probably generally okay. You could clean it. You could distribute the x to the 1/2 in, or turn this back into a root x. But I think kind of what we're going to need this for. This is pretty darn good. Well, actually, sorry, no, strike that. We can do one better thing here. Take out a half from both of them. So yeah, let's clean that up a little bit better. F prime of x is arctan root x plus the x to the first over x to the 1/2 cancel to give you root x on top because x to the 1/2 on top, and then 2 times the quantity x plus 1. Yeah, that's a bit better. All right, next example. Inverse cosine of 3x squared. So if you need a little bit neater one to see it from, inverse cosine of 3x squared. Okay, so they should have called this like y equals, but the book I pulled it from didn't. So this would be dy dx on the left hand side. Well, the derivative of inverse cosine is negative 1 over square root of 1 minus whatever x is. Well, this is really x here, so 3x squared squared. But then times the derivative of the inside for a chain rule, so it's times 6x. So that gives us then really negative 6x on top. The denominator is 1 minus 3 squared is going to be 9. X squared is going to be x to the 4th. There we go. All right, and then the last one. Okay, let's make it a little more readable for you. Inverse secant x quantity squared. Okay. So derivative for secant is, or inverse secant is 1 over x times square root of x squared minus 1. So we'll do this one again if it's y equals. This is really a power rule problem. Let's take the 2, drop to the front. 2 times secant negative 1 of x to the first times the derivative of secant x, which is really just this guy. So to clean all that up then, 2, because this is to the first power, so I can drop that, inverse secant of x all over x times the square root of x squared minus 1. There we go. The worst that would have happened is maybe this would have been 3x cubed or something like that, which would have been another chain out there, and it just repeats itself. All right. If you have any other questions, come in before school tomorrow morning. I'll be around, and yeah, have fun.